Hi everyone, this is a video about standard deviation, but before we get into that, I want you to think about this. We've got two students, Adam and Bonnie, and they're comparing their quiz scores, and they're trying to work out who's the best student. So we're going to help them by calculating the mean, median, mode. Why don't you try and do that now real quick, and you'll see the answer in a second. Have you got the mean, median, mode? Here are the answers. They have the same mean, the same median, the same mode. Oh my goodness, how am I going to work out who's the best? Well, sometimes central tendency, mean, median, mode, aren't the best ways to work out who's the best. We also need to take account the dispersion or the spread of the data. Well, let's have a look at their numbers again and think about range. How across what range do the numbers spread? Okay, which is the largest number, which is the smallest number, what's the difference in between? So range is basically just largest number minus smallest number. So for our set of scores, Adam's largest was 105, his lowest was 60. Bonnie's largest was 90, and her lowest was 10. So that would suggest what? Well, that would suggest that Bonnie's scores are more consistent. Therefore, you could say that she's better than Adam. Okay, because she's more consistent. Adam just has his good days and his bad days, but Bonnie's always about the same. So that was useful, but a more useful measure of dispersion or spread is called standard deviation. We're going to go through how you calculate that and what it actually means. But first thing we're going to do is look at just deviations. What does that actually mean? Well, deviation is the difference between a data point and the mean. So difference is in minus. So we look at every single data point x and we subtract the mean from it. So if it's close to the mean, it's going to have a small deviation. If it's away from the mean, it's going to have a large deviation. If you add up all the deviations, you should get 0, because the mean will be right in the middle of the data. If you don't, you've made a mistake. And the mean of the deviations is always 0, because the sum of them is always 0. So 0 divided by something equals 0. So that's kind of a useless second statement there, but it's something to remember. So if we look at the deviations, they both had a mean of 84.5. So if we take each of their numbers and each of their data points, each of their test scores, quiz scores, and you take away 84.5, these numbers here are the deviations. So if they get more than the mean, it's a positive. If they get less than the mean, it's negative. And when you add them all together, you get 0. Same with Bonnie's scores. And you see her deviations are less because she's more consistent. But when you add them all together, you still get 0. Okay, let's have a look at, keep going. So that was deviations. Now, you had positive and negative, so to get rid of the positive and negative, we're going to square it, and we're going to sum them all together and see what happens then. Okay, because your mean deviation is always 0, we're going to modify it, and we're going to call this thing variance. Now, it's a little bit annoying for most people because variance is the square of standard deviation, but so they like to work out standard deviation, but think of variance as the mean of the squares of the deviation. So that gives it an extra meaning. Okay, so if we worked at the variance, we've got all the deviations, there's all Adam's deviations, all squared divided by 6. All squared and added together, divided by 6. So his variance is 237. That's rounded to 3 significant figures. Okay, Bonnie, you'll see her deviations all squared, added together, and divided by 6, because there were 6 quizzes. And her variance is 10.9. So that's variance. Sometimes on tests you'll be asked to do variance, so it's important to know what variance means and where it comes from. But more often you'll be asked for standard deviation. And standard deviation is basically just the square root of what the variance is. Okay, so in this case, Adam's standard deviation was 15.4 and Bonnie's was 3.0. And we know that because her standard deviation was much less, she's much more consistent than Adam. So yes, I would suggest she's better. Right, we're going to take this a step further. We're going to look at another example now. I'm not going to tell you the context of this, but basically there's some situation where the answers were 14, 15, 17, 18 and 19. 5 people got 14, 6 got 15, 7 got 17, etc. So how do we now find the standard deviation of this? Well, the mean is 16.5. How did you get that? That's 14 times 5 plus 15 times 6 plus 17 times 7, etc. all over 26. And you get 16.5. We're going to use this formula to work out the standard deviation of this. So from 1 to k, so that'll be 1, 2, 3, 4, 5. So for each of these 5 values we're going to have a sum that has 5 terms, and it'll be 5 f1 5 times 14 minus 16.5 squared, and then we'll add up the rest. So it's going to look like this. Okay, that's 5, that's f1, that's x1, that's x bar, that's f2, that's x2, that's x bar, etc. And then n is these numbers all added together, which I know is 26, so I probably should have just written 26 there. Okay, now I type that all in my calculator, work it all out, I get 1.8. So the standard deviation, that is 1.8, which makes sense. The mean is 16.5, which is a number kind of halfway in the middle of these numbers, and standard deviation is 1.8, means most of the numbers are within 1.8 of 16.5, which makes sense. Okay, like 16.5 plus 1.8 is 18.3, so most of the numbers are less than 18.3. 16.5 minus 1.8 is 13.7, and there you go. So most of the numbers are greater than that, which is what the really standard deviation is all about. A small standard deviation means the data is close together. A large one means spread apart. But more helpfully, when you've got a normal distribution, and I'll show you what that is, you can assume that 68% of the data is within 1 standard deviation of the mean, and 95% is within 2 standard deviations. Here's this graphically. Okay, so if your data is sort of distributed in this sort of fashion, with most of the numbers around the mean, less numbers at the beginning and down low, and less numbers up high, okay, then you can say that, okay, there's your mean. 68% of the data will be within 1 standard deviation of the mean. 95% will be within 2 standard deviations, and 99.7 will be within 3 standard deviations. Okay, that's the power of the standard deviation. By the way, the other thing about normally distributed data is that half the data is below the mean, half the data is above the mean. That'll help you think about this a bit better. Okay, final question. If we look at a race, and we record it in seconds, normally we do it in minutes and seconds, but we've just got seconds here to make it easier for ourselves. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 individuals here, and this was their time to complete the race. Now, this person, the fastest person, did it in 140 seconds. I want you to prove to me that that's a really exceptionally fast time. Well, you could say, well, the mean, I worked it out, is 156.5. Well, he's 16.5 seconds better than the mean. That's like more than 10% better than the mean. Yeah, good try, but that's not really telling me that it's exceptionally fast. What you also need to say is the standard deviation is 8.15. So 16.5 is more than 2 times that. So 140 is better than 2 standard deviations better than the mean. That means he's better than 95% of these people. He's in the 95th percentile. So this is a very good time. That's the power of standard deviation. Okay, you need to learn the formula, but use your calculator to work it out as well, which is what I did here. And I hope this theory and these examples will help you understand it better. See you again.